Okay, we're going to look at worksheet G, molecule polarity simulation, molecular polarity simulation. And so I've got the first molecule set up here, so it looks pretty linear. And notice the greatest electronegativity is actually on C, so you can see the adjustments here. And we're going to watch what happens when we turn on this field. And so right now, there's the positive side, the negative side. Just spin this around to see if anything happens. Notice that it's arranging itself so that C is coming back to being attracted to the positive, and that A is being attracted to the negative. If we look at the overall molecular dipole, notice it is the electron density is being pulled in this direction, meaning that C has the partially negative charge, and then A has the partially positive charge overall. All right, moving on to the second example. We have that. And make sure it's nice and linear. I think I don't have there. As linear as possible. Okay. So again, spinning it, it's just kind of floating there. It doesn't seem to be, one side is not being pulled one way or the other. Okay. And again, we don't really see any overall molecular dipole, so that was nonpolar. Going to our third scenario, now we've got the vent set up here. Let's rotate that so it looks like the picture. And except we've got the different electronegativities here. That there and that there. And there we go. So that is like it is in the picture. So notice the side that's being attracted towards the positive side. And that's because our partially negative side is both A and B, sorry, A and C, and the partially positive end is the B end. Go. Okay, moving on to the fourth scenario here. Just make it look just like the picture. And E has the greater electronegativity, and C and A. There we go. Turn it on. Oh, and so notice the electrons are being pulled towards the B side, and so that side of the molecule is drawn towards the plus positive plate. All right, and then the last setup is like this. And turn on the field. So notice the C side of the molecule is being attracted towards the positive, the A side is being attracted towards the negative, and that's because my molecular dipole is in this direction, towards the C atom. All right, next we're going to look at the real molecules. So this is after you have already drawn the Lewis structures and made your predictions. And let's take a look at N2. So this is a linear molecule, two atoms of the same type. So notice both have the same electronegativity, so there's no pull one way or the other. So it's nonpolar overall. We have water. You should know the polarity of water already. However, take a look. Notice the oxygen partially negative, hydrogen is partially positive. So there's those partially positive negative charges. Again, the electronegativities, you can tell which way the electrons are going to be gone. All right, then we've got BF3. So electrons being pulled towards chlorine. However, notice since this is that trigonal planar shape, that all cancels out. There's no overall molecular dipole. So there's not one side that's partially positive or one side that's partially negative. Right, so if these F's are all partially negative 0.28, well, there's not a partially positive side sticking out because that B is kind of trapped in the center. All right, and then we've got HCN. There you are. Okay, so again, that's linear. But notice the N with the highest electronegativity, electrons are pulled towards that side, so that's the side of our partially negative on our molecule. And because there's not an identical nitrogen, so even though this is linear, there's not an identical nitrogen on the other side. It's got hydrogen. It's not the same atom. It's not pulling on electrons in the same way that nitrogen does. So that's why we don't see this linear shape balancing out. So that's important to notice if we have a symmetrical molecule on both ends or not. And lastly, CH2F2. So there you go. So again, notice things are being pulled towards the fluorine side because those are more electronegative than C and then the H's, and they're partially positive side on this molecule, on this side of the molecule, and partially negative on this side. And there you go.